All right, what's up, my athletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to take a look at an application of a conics problem involving hyperbolas. So let's go ahead and grab our note sheets and let's go. So in this expression, or this problem, they tell us it's a hyperbolic mirror. So we don't have to guess what kind of shape it is. They straight up tell us, which is cool. And it's used to take these panoramic photographs, and the camera is pointed towards the vertex of the mirror and is positioned so that the lens is at one focus of the mirror. An equation for the cross-section of the mirror is given by this equation: y squared over 16 minus x squared over 9 equals 1, where x and y are measured in inches. How far from the mirror is the lens? That's a lot of words, so let's kind of break this apart. And we'll start by analyzing and drawing our graph first. So let's take a look at our equation. We've got a y squared minus over 16, so that means this number right here, when we look underneath here, that means the a value. If I square root 16, I know that's going to be 4. And then the b value is going to be the square root of 9, of course, which is just 3. So I know these two values right here, so this is going to help me sketch a couple of things about my hyperbola. And then we'll start to put the words together to make this. So let's go ahead and draw our little hyperbola here. So we know 1, 2, 3, 4. We're going to go up 1, 2, 3, 4 and go down. So those are going to be where my vertices are. So I'm going to put a dot right on there and right on there. So that's going to be the vertex. Now the co-vertices are going to be 3 units to the left and right of the center. So I'm going to go 1, 2, 3 to the right and 1, 2, 3 to the left of the center. And those are going to be my co-vertices. So we will now draw our little box around our shape here to come up with where the corners of the box are going to be to help me figure out what the asymptotes equations are going to be. So from the center, I'm going to count up 4 and over 3, so that's going to give me that right top corner. And then I would do the same thing going down to the left, and then I start in the opposite corner, so we got our two little asymptotes drawn there. Now, the equations for these asymptotes, remember, if you get confused whether it's plus or minus a over b or b over a, just kind of look at where the hyperbolas are, and the hyperbolas, this one's going to go up and down, like that. So that means I'm going to count from the center, up and over, rise, run. So those two pieces, I'm going to have plus or minus. The rise is 4, and the run is 3. So I'm going to have plus or minus 4/3 x. Those are going to be the equations for the asymptotes. So that's pretty cool, but that's not really helping us out here with too much stuff. Now let's go back into the words here. A camera is pointed towards the vertex of the mirror, and its position is so that the lens is at one focus of the mirror. So the focus, so I'm going to write this right here, and I'm going to put a little F there for focus. And the focus, what does that represent? So that is the lens, is that one focus on the mirror. So I'm just going to write lens right next to that. So that's where the lens is. And then my vertex, the vertex, that is going to be the mirror. So I've got my mirror that's right there at the vertex. So the mirror, the vertex, and like how far from the mirror is a lens? So really what we're trying to find, how far is that distance? We're trying to figure out how far it is between the vertex and the focus, or the lens and the mirror and the lens. To do that, we need to figure out the c value, because we already have our a squared and our b squared value. So a couple different equations we could use to find that. One of them is c squared is going to be a squared plus b squared, and c squared when we find the value of c. So let's find that. Now we know that a squared and b squared, so that's 16 and 9. That sum gives us 25, and when we square root that, we know we will get a value of 5. So now that we found our c value, what we're going to do is kind of go back and think about this, because they're asking how far is the mirror from the lens. So when we take a look at that, the lens distance minus the mirror distance, however far those both are from the center, that's what's going to help us. Now the lens is the focus, right? So that focus value, because we know that that's 5, and the mirror value, that's actually our vertex, right? So we're going to find the distance between the focus and the vertex, and the focus is 5 away from the center and the vertex is 4 away, which means that the distance is going to be 1. Now we'll wrap this up with a nice complete sentence. in which case we say the mirror is 1 inch from the lens. So it's really important to include not only the number, but also the units. So points wise, you know, if this were quiz, like, okay, we've got that value, the mirror is 1 inch from the lens in a complete sentence. We've shown our calculations how to come up with that distance. We've figured out the value of C, and of course you're gonna have a drawing that's gonna have all those key components in there, the center, the vertex, and the foci, and of course the asymptotes. So all of those will need to be in your picture, as well as the 2 hyperbolas as well, or the 1 hyperbola. So make sure you have all those pieces. Thank you guys so much for watching. And as always, get out there and make it a great day. And I'll catch up with you soon. Peace out.